Hi, hello, and welcome to the Hybrid Container Days 2022. And thank you for watching my session, Making Your Microservices Multi-Cloud Ready with Dapr. I'm David, and I will be guiding you through the hyperspace of the Dapr universe today. So let's dive right in, shall we? So, if you are watching this session, you probably have the same question I have. Decoupling microservices from your cloud infrastructure is hard, isn't it? Well, what if it could tell you that there is something that could make your life a whole lot easier? And that something is Dapr, the Distributed Application Runtime. So it's a service founded in 2019 by Jeroen Schneider and Mark Vassel. They're two ex-Microsoft employees that now work for startup and open source incubators. And they created Dapr out of the need of creating a hybrid between a service mesh and an application runtime that could run microservices with ease on a containerized environment, for example, on Docker, Swarm, or Kubernetes, without having to spend a lot of time on maintaining or setting up cloud infrastructure, and while also tackling common problems with microservices architectures, such as state management. So, So the first version of Dapr was actually released in October 19, 2019. That was the pre-release version of Dapr 0.1. They went stable in the end with Dapr 1.0 in February 2021, so quite recent. So there's still lots going on in the project, but I think that also makes it a really good project to watch out for, because they are going to be really agile in making changes and also putting in feature requests from the community. So actually, 3 days before they released the first ever version, Microsoft released a press statement with the following quote: "We predict that by 2022, 90% of new applications will feature microservices architectures." And I don't know much about you, but it's 2022 right now. Has that come true? I think in the end, my personal experience, we're not hitting the 90%, maybe 70, 75. We all know microservices is not a fit for everything, but at least Microsoft invested heavily into this paradigm and therefore also backed the Dapr project financially, albeit it being open source, quite a lot with people, knowledge, and also money to make it a success. Because strategically, Microsoft has decided to have Dapr replace Azure Service Fabric, which has been discontinued quite a while ago. And they actually want to have Dapr in that place to fill that void between the hybrid, between the service mesh and the application runtime. And you see them doing that right now already with Azure Container Apps, in which Dapr has a prominent position. But this quote really acknowledges Microsoft's pledge into making Dapr a success. And I think in the end, that's also what helped the project grow from the start. So, all well, but what does Dapr actually do then? Basically, Dapr abstracts away all cloud infrastructure from your application code and configuration. So you could you literally can change your infrastructure without touching any application code. It codifies the best practices for building microservice applications through providing a whole variety of building blocks. And it creates a set of independent APIs, which are either reachable over HTTP or gRPC, to interact with those building blocks. So this is basically the main overview of the Dapr project. So one of the main benefits is that it's agnostic on both sides. So on top, you'll see your application code that's running your application, interacting with Dapr over the HTTP or gRPC APIs. And you'll see that application code can be anything from Go to Node to Java to .NET to C#, C++, Python. That doesn't really matter as long as it can utilize one of those APIs that are exposed by Dapr, you're fine. And on the bottom, you'll see a whole variety of cloud infrastructure providers like Microsoft Azure, AWS, GCP, and Alibaba. And on that end, Dapr is also agnostic because it doesn't really matter what cloud you are using. Dapr has integrations with all of them, and you can switch them intermittently between one or the other without your application code ever needing to know. So I think that is the basic construct. And then in the middle, you'll see all of the building blocks that Dapr has to provide services for your microservice applications, on which we'll go into shortly. But first, let's have a closer look at how Dapr actually works within your application. So, as I already stated, it's paramount that you use a containerized architecture if you want to use Dapr. Basically, if you're not using containers, you cannot use the runtime. That is because Dapr utilizes the sidecar mechanism, which multiple other service meshes that work in containerized environments also use to attach to your service pod or service container. So basically what happens, Dapr spins up a sidecar container whenever you're using one of their APIs inside your microservice. So your microservice will communicate securely over MTLS with your Dapr sidecar inside your Docker Swarm or inside your Kubernetes cluster, and use those Dapr APIs to do all of the heavy lifting that you want them to do. So for some building blocks, Dapr needs outside resources like state stores or a Redis cache or a Cassandra or a Cosmos DB, or it needs access to a service bus or a RabbitMQ. But the sidecar all handles that. So basically all the infrastructure components that you've connected to Dapr will communicate through the sidecar over the Dapr APIs with your service code. So your service only sees the Dapr sidecar and nothing else. So these are those Dapr building blocks that I talked about earlier. So we have some orchestrator ones like service-to-service invocation and state management and publish and subscribe. We have some configuration ones like app configuration or secrets configuration that can be easily abstracted away via Dapr. And we have some other concerns like observability, actors, and bindings that Dapr can handle for you, so you don't have to manage those in your application code. So I think it's time for a demo. So here we are in the IDE. So I just opened a new terminal, and basically I've installed Dapr already and added the Dapr.executable to my path environment variable. So if I now run Dapr with just a Dapr keyword, it will come up with the CLI. So first time you would have Dapr installed, you would hit Dapr init, and it will show you that it will make the jump into hyperspace and pull the container images from Docker Hub. So you would need to have Docker desktop running to do this, but it now says that it already exists. So I already have Dapr, and if I can check which version I currently have, so I see there is a 183 available. I'm currently running on 171 CLI, 173 runtime, so that's fine for now. So we can just run that. That's it does not work. Not a problem. Okay, so now let's go actually check that Dapr is running. So I can go here into my Docker desktop, and it will show me my Docker desktop hub, and it will show that I have a Dapr placement container running, a Dapr Redis. This is actually the Dapr port, so it's running on 60,050. It's running the Redis cache, which it uses by default to do the state management. This is a Redis cache container, and it uses Zipkin for doing some zip operations. It also has a separate container for that. So it's running fine, no problem. So say I would want to save some state to pass that on from one service to another. What I can then do is I can run my app. So I have an app called Rockstars, which runs on HTTP port 3500. So it's now starting up Dapr and say, yeah, so the sidecar is up and running. So basically this means that I can use the Redis cache to put some stuff into my state store. So therefore I have this command. I'll open up a separate terminal window. So I'm going to do a post to this localhost 3500. 3500 is where my Dapr instance is running on, because I said Dapr HTTP port 3500. You can also now see that in Docker desktop that you're already running on something running on 3500. Oh, it's not showing yet, but it should work. So if I do this, oh, sorry, if I need to open up a PowerShell command here. So I'm doing this. It will actually post data to my state store. And if I then go back to my URI here, it will actually give me back the state, which you put in there. So it basically just an HTTP API with name being the key and my name being the value. So I use the name in the get rest method. So I can also do that here from the command line. So if I put this in here and I then put in the state store and I put in /name, it will come back with my name, which is fine. So I can now pass this on to some other service. Some other service can do some mutations on this, and it can actually update. So I can also do a put on this if I want to change it. So to show you that you can actually also put this, explore this as it is a Redis cache. I can use here, connect with Docker to my Redis CLI. So I can list all the keys that are in my state store. So you can see I have a key Rockstars and I have a key name. So if I go back to my localhost and if I put in Rockstars here, Rockstars, it should actually find that. So let's do that. And then it will give me back that I have got data in there. So the app is called Rockstars. my state store key is name. The data in there is my name, and it also has it also keeps track of the version. So I can actually, if I post this again, it will update. So if you want, I can also do a put here. So let's exit this terminal. I can also put in. So now we're not going to actually do much. So I'm going to change this to a put, and to actually change this to name to hoop. Special agent, which is my job title for Team Rockstars IT. Hit it on the state store. And then you'll see here, if I refresh, if I refresh here, it will actually have updated. And if I go back to my IDE here, and do a Docker to go into the Redis CLI again, and I'll do a get all. You can see now this is version 7. So this property with key name has already been updated 7 times. So it keeps track of the history as well, which is cool. So of course, you can also use some other type of state store if you want. The Redis comes out of the box. With Dapr, you can also use some cloud stored ones, but this is basically how easy it is to set up an application with Dapr and to interact with the state store and then pass it on just via a single HTTP API, REST API between multiple services. So yeah, let's get back to the presentation. So as I already stated before, Dapr isn't exactly a service mesh. And I created this picture to actually show you why. So a service mesh traditionally has networking controls. So you have a service mesh on the infrastructure side that does traffic splitting, traffic routing, load balancing for A/B testing, and all kinds of stuff. So Dapr doesn't do that. Dapr lives on the developer side of your application code to do your state management for you, to do service-to-service invocation, to manage your resource bindings and triggers, and manage your secrets, but it doesn't have capabilities for network-level controls. So if you want, you could use Dapr with a service mesh, but it cannot replace your service mesh, at least not if you need those network level controls because you're in a company policy that restricts, that dictates that your application need all your traffic encrypted end to end, or if you have a load balancer in front of your infrastructure in which you want to do traffic splitting for A/B testing or for blue-green deployments, then you need to be stuck with a service mesh. But if you want to, you could use Dapr with a whole variety of service meshes. It works well, and it's tested with most of the industry standard ones like Istio, Linker, and Open Service Mesh. And since Dapr works with this from the same sidecar principle as all those other services, you'll basically have more than one for your microservice. So if you're using Istio, your microservice will have a sidecar for Dapr. It will have a sidecar for Istio. It will communicate over the Istio APIs to the Istio sidecar, and will communicate over the Dapr API to the Dapr sidecars, and they won't be in the way of each other. So if you're thinking about using Dapr to replace some of your service mesh capabilities, please keep in mind these requirements. So if you do need traffic splitting or load balancing requirements for A/B testing or blue-green deployments, or if you have an enterprise-grade network in which you have requirements for end-to-end encryption of all traffic to be compliant with networking policies, then you still need a service mesh. if you're running on public cloud that is not a VNet connected in any way, or if you do your blue-green deployments or A/B testing some other way, you can perfectly use Dapr without a service mesh. There's no need for you to have low-level network control then, and you can just create it in a cluster in which you use less compute and you'll be more agile. So if you don't need the service mesh, then don't add the complexity of using that. So one of the other benefits that I think Dapr has, which is not one of the intended benefits, but actually comes as a bonus, is their opportunity to implement multi-cloud. So I already hear you thinking, yeah, right, multi-cloud, I don't have a problem with it. Why do I need to do multi-cloud? People often react, but in the end, if you think about what multi-cloud actually is, you realize sooner rather than later that the chance of you having a multi-cloud setup is already quite high. Because according to the Flexera 2022 State of the Cloud report, it says 89% of companies reported having a multi-cloud strategy. And the first time I read this article, I also thought, well, that is quite high, isn't it? Like, that's 9 out of 10 companies. That's like almost everybody. Like, I don't see that in practice, but there is a catch. So actually, Flexera also categorize a hybrid cloud environment as multi-cloud, which you could debate on if it's fair or not, but that you get why you get that such a high number. But actually, what Dapr's multi-cloud capabilities are designed for is for multiple public cloud usage. And if you can see in this diagram, only 7% of companies having a multi-cloud strategy use multiple public clouds. And why is that? Well, that is because it's a pain to manage multiple public clouds into your applications because they use different APIs. You have different authentication mechanisms, different application configuration mechanisms. So it's just really hard to combine them together. And I think Dapr has the perfect solution for that, as it abstracts away all that configuration from your application code, and it has already ready-made connectors for all those widely used public clouds that you would probably want in a multi-public cloud strategy. So your benefits of having a multi-public cloud strategy is that it's more cost efficient, because some services like storage is way more cost efficient on AWS, and stuff like identity access management is way more cost efficient on Azure. It will ease migration paths if you have dependencies on a certain service from a certain provider, and you'll prevent vendor lock-in. And you can use the best service that fits your application's requirements, regardless of in which cloud that is available, which will in the end also make your development teams a lot happier because they can use the service that they want and that is best for their solution. So as I said, with Dapr, you can actually decouple all your cloud infrastructure invocation and configuration. You can seamlessly switch cloud providers, even between public clouds and on-premises if you would want. And you can benefit of the vast amount of building blocks that are already available within the Dapr community to connect to all kinds of public cloud stuff. So here you can see a list of all the services that Dapr currently has a binding for, or a building block, or a connector, or how you want to call it. So you can see for GCP, AWS, and Azure, it's basically all of the widely used public cloud services that you would use for a cloud native application. Things like Redis Cache, MongoDB, Cosmos DB, Postgres databases, MQTT, Kafka, RabbitMQ, Azure Key Vault, Secret Manager, HashiCorp Vault, S3 storage queues, SQS storage, DynamoDB, SignalR, you name it, and it's there. And you don't have to worry about switching stuff around. So you could perfectly store your states in a DynamoDB because it's way more cost efficient than a MongoDB on Cosmos. Or you could definitely use an Azure Key Vault because of the Azure Active Directory integration instead of having to use AWS Secret Manager. So you have a vast amount of combinations and possibilities in front of you if you have Dapr between your application code and your cloud infrastructure. So let's go into a demo and I'll actually show you how seamlessly you can run your application without having to touch your application code and switch between an on-premise secret store and a public one in the public cloud using Azure Key Vault. Here we go. So I have a terminal again. This time we are running an actual app. So I created a .NET 6 app, which is just a web API MVC controller, which is called Secret Controller, which has one API controller with a route to the home with one get method called getSecret, which will get a secret. But this will not get a secret directly from, for example, an Azure Key Vault client, but it will use the Dapr client. So in the constructor, I'm injecting a Dapr client, which is configured on startup. So in program CS, I put into the host builder that I want a new Dapr client builder and that I want to add a secret store called demo secrets. So basically here I tell my host builder, I want to use the secret store that is configured in the demo secrets component because all Dapr configuration is stored in components. And I just want to use the web builder startup as usual and use a singleton Dapr client. So I only have one in my entire application running at the same time. So I here have a components folder, which has two YAML files, which are the actual Dapr components. So I actually have two. So I have one secret store, which is a local file. So this is a local file storage that has some secrets in them. I put them in my C root folder. And I have a component file that actually is an Azure Key Vault secret store. So it talks to this Azure Key Vault with this Azure Tenant ID, and I put in a service principal here to be able to connect to it. So back to my secret controller. My secret controller knows nothing about this. The only thing my secret controller knows is talking to the Dapr client, and it wants to get the secret named not so secret from the secret store demo secrets. That's all that my application knows. The rest of the magic is handled by Dapr. So let's go. I'm going to open up a new terminal here. So I have to go into my folder for my actual application. Otherwise, my run will not work. So what I'm going to do, I'm going to inject Dapr with the .NET Run, which will actually execute my .NET 6 application. So I tell Dapr to look at this folder, components, where all my Dapr components are, and I'm just going to run a regular .NET Run injected with Dapr. So it's going to start up the Dapr sidecar first, and now it's going to run my app. So I have my app as HTTPS on localhost 5001 and on HTTP localhost 5000. So it should now print, because I've told Dapr to go look at my demo secrets and not at my demo secrets 2, it should now print the secret from the local file. So if I go back to my browser and I type in HTTPS localhost 5001/secret, I'll get Dapr secret store assurance, Dapr is awesome. So this is the secret I stored locally. Say at some point I'm moving my secrets to the cloud because I want to have integration with Azure Active Directory and such. The only thing I have to do is to change my component. Now this becomes my demo secret store, and this becomes the demo secret store old. This now talks directly to an Azure Key Vault, provided you have the same secret names in there as you had locally. Only thing I have to do now is I have to restart my app. So I'm going to kill my app and then run it again. And now I'm going to hit the endpoint again. It will give me back my secret from Azure. And to prove to you that it's actually coming from the cloud, you can here dive into my Key Vault. Let's open up this Key Vault. Not so secret. You can actually see the value here. It's the same as what Dapr gives me back. So without ever having to touch one single line of application code, I've now just brought my secret store to the cloud. And I think that this is one of the key benefits that Dapr has. You do not have to fiddling around with configuration, no endless code reviews. You had it on premise or you had it on AWS first. You put in a new Dapr component and you have it on Azure. Do one restart at night and you're done. So as you have seen in the multiple demos today, you can use Dapr with one of the building blocks to make your life easier developing microservices. You can also use Dapr to make some really neat multi-cloud microservices that you can release and put on any cloud, mix multiple clouds together, and actually use the service that is best intended for your requirements. So Dapr is really fast moving. They just released version 1.8.3, and I think my demo that was just a month old is still running on 1.7.1. So they're going like crazy. It was released on July 28th. They have really good documentation. Microsoft has also heavily invested in technical writers for the Dapr project. So their documentation is really good. And on Microsoft, they have a Discord channel in which you can find a lot of information. If you want to get involved with the Dapr community, they have bi-weekly community meetings in which they talk about feature requests from the community, get feedback, but also announce new things. So the next one after this presentation will be on Wednesday, the 7th of September. They're all at 9 a.m. Pacific time, which is 6 p.m. here in Europe. So that's perfectly a great time after a day of work to go watch one of those meetings. They are recorded and being put on YouTube after, so I'll put the link here. And if you want to join, you can use Zoom. The meeting invite is at the bottom, and you can always find this presentation back on my GitLab, so you can get the details from there as well. If you want to join, or you can just search on GitHub for the Dapr community meetings, and you will find it as well. So thank you very much for watching this session today. I hope you are really enthusiastic about Dapr as I am, and I hope you're going to create some really cool multi-cloud microservices with it. If you have any questions, reach out to me on Twitter or LinkedIn or GitLab. I'm more than happy to answer them for you. You can also find all of the example code that I used for the demos on my GitLab. And I hope you have a great day here today and tomorrow at the Hybrid Container Days 2022. Goodbye.